In the last segment, we saw, by example, that single replacement, combination, combustion are also redox. And we can show that by assigning oxidation numbers and seeing how they change. In this segment, segment 4, we're going to look at the last one, and that's double replacement. Lithium plus, nitrate minus, potassium plus, bromide minus, potassium nitrate is soluble, K plus, NO3 minus, lithium bromide, Li plus, Br minus. Our net ionic equation is that lithium doesn't change, nitrate doesn't change, potassium doesn't change, and bromide doesn't change. So nothing has been oxidized, nothing has been reduced, and there is no net ionic equation. Okay, so you are going to want to practice. There should be ample exercises on this on Blackboard for you and/or do problems as assigned. Now, one additional concept is what we call an oxidizing agent or an oxidizer, and a reducing agent or a reducer. An oxidizing agent is something that causes oxidation. So let's say, for example, for my little visual aid, that I have this compound over here, and I am going to be the oxidizer, and I am going to take this electron away. When I take this electron away, I myself, as the oxidizer, am being reduced. Or I can be the reducing agent, which is something that causes reduction. So now my electron, I am going to cause this compound over here to gain that electron. And by me giving that electron away, I am the one who is oxidized. So understanding oxidizing agents when we see them or reducing agents when we see them is something we want to be able to do moving forward. So let's take a look at a few more. +1 on the hydrogen, -3 on the nitrogen, -2 on the oxygen, +4 on the nitrogen. So the number goes from -3 to +4, so NH3 is oxidized. It is oxidized. Therefore, because it is oxidized, we could use it as a reducing agent. Therefore, NH3 is a reducer or a reducing agent. H plus to H2, if we want to balance it, we certainly can. This goes from +1 to 0. So the number goes from +1 to 0. So H plus is reduced. It is reduced. If it is reduced, it acts as an oxidizer. Therefore, H plus is an oxidizer or oxidizing agent. Just like our reducer is a reducing agent. Our dichromate, oxygen is a -2. Everything has to add up to -2. So 2 times the number on chromium, -14. 2 times the number on chromium, -14, has to equal -2, which means that the number on chromium is +6. When the number on chromium goes from 6 to +3, that is showing that the dichromate, we can write this in a variety of ways, is reduced. Therefore, dichromate is an oxidizer or is an oxidizing agent. Okay? And then last on the list here is the oxygen not combined, O2 minus. It has to be combined with something else. That's why we spent all this time on net ionic equations. It's combined with something else. It's just a spectator. Just like hydrogen has to appear somewhere else over here, we're just ignoring it. And oxygen has to show up over here, we're just ignoring it. Okay? So 0 to -2, therefore the oxygen gas is reduced, and therefore O2 is also an oxidizer. So if I wanted an oxidizer, I would use H+ or dichromate or oxygen gas. It just depends on my application. If I wanted a reducer, I would have to use the only reducer that I have here, which is NH3. Okay? I can go back to the other ones on page 4, and if SO2 shows oxidation, then SO2 is a reducer. If permanganate is reduced, then permanganate is an oxidizer, etc., etc. So go back to the ones that we've done on the other pages and assign, are they oxidizers or are they reducers? Now the burning question is, well, why do we care? Why do we care about whether we have oxidizers or reducers? Well, we're going to come back to that when we get to basically some biochemistry. The idea of oxidizing agents or oxidizers is going to become really huge because our ability to create energy comes from the transfer of electrons or a series of oxidation, and we end up having a final electron acceptor, and that is that final thing which is reduced. So moving forward, what you absolutely want to be able to do is to recognize redox when you see it. So in this class, we start with the basic skeletal equations, then we look at oxidation numbers, then we look at oxidizers, then we look at reducers. The next segment will change gears and we will begin Introduction to Nuclear Chemistry.